Hello, my students. This is a brief addressing of, if asked to analyze accuracy and precision in AP Chemistry, how would we do it for the problems of Chapter 1 as well as any kind of lab situation? Well, just a refresher. If you're playing darts, the goal is bullseye. The proximity of the dart to the bullseye is a reflection of accuracy. If we're doing a lab and trying to replicate the exact density of water at a certain temperature, and let's say at that temperature the density we know theoretically is 0.99785 gram per mil, how close is your experimental value to that actual value? That is accuracy. Where if we're shooting multiple darts, how close they are to each other, the agreement amongst your data, that is precision. Here are the official equations that will follow whenever we are analyzing accuracy or precision. In honors chemistry, we just referred to accuracy really as error and then percent error. Error, which now in AP Chemistry we're calling absolute error because we're always taking the absolute value, it's just the difference between the actual or the experimental and the observed or the theoretical. Or we could actually have these be vice versa. The actual could be what you've obtained in experiment and then call this your theoretical. But it's the difference between the two. And of course, the closer or the smaller the difference, the greater the accuracy. Where relative error is what we refer to as percent error, and we'll continue to refer to as such in AP Chemistry. And that is where we took theoretical minus experimental divided by theoretical times 100. This is just another approach. Now, I have an example for us to take a look at. And the main thing to be on guard about when you're calculating accuracy is that you're following significant figure rules. So if you want to pause and take a look at my work, the sig figs should make sense. Precision is the agreement amongst the values. The theoretical value plays no role in any of these calculations because we are looking at the agreement of the data amongst itself. The first thing I highly suggest is calculating the mean first, then the absolute deviations, which you will have an absolute deviation for every one of your data values, the average deviation, and then relative deviation. The best way to express the deviation is by writing the mean and then plus or minus what your average deviation is. That shows you your average, if you will, of your data values and then how much they vary amongst each other. Here is my example for a precision calculation. Please pause, analyze this, make sure that you're obeying sig figs. I did make an error. This needs to be multiplied by 100, and these should have the units of gram per mil on them. Of course, gram per mil, gram per mil.